Hello students, welcome to you all. So today we start our discussion with the differences between microprocessor and microcontroller. So students, as you all know that microprocessors and microcontrollers plays a significant role in the everyday functioning of our industrialized societies. So when we move on to the differences between the microprocessors and microcontroller, the first question that is raised in our mind is, why do we learn these microprocessors and microcontrollers? So students, these processors and controllers based electronic systems that what we see nowadays are found in everywhere. So they are not found only in computers and smartphones. They are also found in testing the products and in our day-to-day life, speed controlling of motors, traffic light controllers. Not only in that, in our consumer electronics such as television, communication equipments and all. And they had already moved to home appliances such as microwave ovens, which are used for cooking the food, and washing machines, which are used for washing the clothes. All these type of systems uses the microprocessors and microcontrollers. So students, the first question is, these microprocessors and microcontrollers acts as the core of the electronic devices. That means we can say these acts as the heart of the electronic devices. So now let we move in depth about what is the definition of microprocessor, then we go for microcontroller, then finally we compare what is the differences between the microprocessors and microcontrollers. So when we move on to the definition of microprocessor, the microprocessor is defined as, it's a multi-purpose, it's a programmable register based device which reads the instructions from the storage device called the memory and accepts the data, and the data should be in the form of binary as input, and process the data according to those instructions and delivers the result to the output devices. So now we move in depth about the definition. So the first thing is microprocessor is a multi-purpose. So as you all know that multi-purpose is more than one purpose. Nowadays, if you take an example of our computer, with the help of our computer, what are all the operations that we can do is we can perform uh, we can perform any mathematical operations, such as we can do any calculation operations in our computer. Not only that, the computers are used for word processing, and the computers are used for video watchings, audio songs we can hear with the help of computers. We can access internet. So whatever we can do, so all these type of applications, we call it as what means multi-purpose. So the processor which we use in our systems, it may be a desktop computers or a laptop computers, it is not only used for a single purpose, it is also used for multi-purpose application. So be sure on that it can be used for more than one purpose. The second one is the microprocessor is a programmable device. What is the meaning of programmable means? So the processor can be instructed to perform the task within its capability. For example, if I take a piano, so it's a programmable machine. Because it's a musical instrument, it is capable of generating various kinds of tones based on the number of keys it has. So it's the responsibility of a musician to select the various kinds of tones, so based on the musical score printed on a sheet. So similarly, when you come to our microprocessor, here the programmer can select the appropriate instructions and ask the microprocessor to perform the tasks on the given set of data. For example, I want to perform an addition operation means I have to select an instruction which supports that addition operation. Similarly, on what data the addition operation need to be performed. So here the microprocessor is a programmable device. And the next one is it's a register based electronic device. As you all know that the registers are used to store the data temporarily during the execution of the program, because the data is very much required to perform an operation. To store the data, we take the help of what means registers. So similarly, whenever an user wants to perform operation, he has to write a program, and that program has to be stored in the memory. So it's the responsibility of the processor to pick up the instructions from the memory and accepts the data as the input and process the data according to those instructions and delivers the result to the output device. So students, similarly, when you look out the diagram here, so this is the center heart, which we call it as the core. It combines a microprocessor, and you will know that microprocessor consists of an ALU, which is defined as arithmetic and logic unit, which performs the arithmetic and logical operations. And we also have a control unit, and you all know that the control unit is very much essential for providing the timing and the control signals. And the next one is the register array, which has a group of registers which are used to store the data temporarily during the execution of the program. And we also have an input device and an output device, and you all know that the responsibility of these input and output devices are: the user can enter the instructions and data into the memory through the devices such as keyboards or switches, and these devices are called as the input device. The microprocessor reads the instructions from the memory and process the data according to those instructions and delivers the result to the output devices. And that output devices may be a 7 segment display, or the output devices maybe, for example, it may be a printer where the data can be printed, and all these type of devices we call it as an output devices. So this is the definition that we can give for microprocessor. Now students, moving on to another one which we call it as microcontroller. So what is the definition that we can give for a microcontroller is: a microcontroller is a single chip which contains a CPU, which we call it as a central processing unit, where your all processing operations are going to take place. That is, simply we can say it is a computational operations. And similarly, it consists of a RAM memory and a ROM memory. And a RAM memory, we call it as a random access memory or read and write memory. And your ROM memory, it's just, we call it as a read-only memory. So here, these two categories of memories are used in our microcontroller, where one is used to store the for example, the user data, and another where the program can be stored. So it also consists of an input and output devices supporting, and it consisting of a timer which are used to generate the time delay, and it consists of a serial communication port where we can convert the data into the serial, and we can transmit the data in the form of bit by bit. So students, if you look out all these components, whether it is a RAM or whether it's a ROM, which consists of a memory area, and it consisting of an IO pins, input and output lines, to communicate with the input devices and the output devices, and the supporting special function devices such as timers, where we require to generate the time delay, we can take the help of the timers. And whenever we want to convert the parallel data into serial data, we can take the help of the serial communication port. All these components are integrated on a single chip. Then we call this one as a microcontroller. And nowadays, many communication equipments such as digital entertainment devices or portable devices, all are controlled with the help of our microcontrollers. Now students, when we go to the requirements, so what do a microprocessor and a microcontroller requirements? As I told you in the previous diagram itself, so there should be a CPU where our computation operations need to be performed. So similarly, a CPU, which we call it as a central processing unit, and this CPU composes of register array, control unit, and the arithmetic logic unit. And your device should also consisting of an input and output, and these input and output are required to provide the instructions to the memory, and the output devices are used to display the output. And we also have a memory, and this memory is been categorized as RAM and ROM memory. And you all know that RAM is a volatile memory which stores the data that you are working on, and ROM is a non-volatile memory where we can store the instructions permanently which are required for your system. And we have a timer, and in our day-to-day life we find several applications where we are going to take the help of generating delays, and in order to calculate the time, and for that applications and all, we take the help of a timer which is inbuilt in microcontroller, and for microprocessor it is externally placed. Now when you go for another topic which you call it as interrupt, and you all know that interrupts are used in both processors and controllers to serve the emergency situations. So whenever any external device requires the help of the microprocessor or microcontroller, they can provide these interrupt signals. And these interrupts may be an internal or the interrupt may be an external. And we also have another which we call it as a serial port. And I told you that, and this serial communication is required whenever you want to transmit the data in the form of bit by bit. Then we can go for a serial communication port, and it also includes a parallel port where you can transmit multiple bits of data at a time. So students, if you carefully look out, the requirements of both microprocessors and microcontrollers are similar. You should have a CPU, I/O, memory, timers, all these supporting devices are also required. But the question is, how do these devices are placed? So now, when you move to the block diagram of a microprocessor, how it looks like means, if you clearly look out here, it consists of a CPU, and I told you that your CPU consists of three sections. One we call it as it consisting of ALU, it consisting of register array, and it consisting of control unit. Followed by this, your microprocessor should have a memory where you can store your instructions and the data, and your microprocessor should have an I/O port which is used for communicating with the input devices and output devices, and your microprocessor should have a timer which is used for generating the time delays or in order to calculate the number of counts. Then also we can take the help of this timer. The next one, we can go for a serial communication port where we can transmit the data in the form of individual bits one by one. And if you clearly look out, all these devices, whether it's a memory, I/O, timer, and serial communication port, all these devices are connected externally to your CPU. Then we call this one as an example of microprocessor. So if you look out here, no RAM, ROM, I/O on the CPU. That means they are placed externally to the CPU. So what are the examples of this one means? We can take an example of a basic processor which you call it as 8086, which has been invented by Intel, and there are also another vendor also. We have Motorola, and it has been represented as 680X0. So these are the vendors which are providing us these microprocessors and microcontrollers. So this is just a description of what your microprocessor. So be sure on that whenever you're considering about microprocessors, the memory, I/O, and timer and serial communication ports are connected externally to the CPU. So similarly, when you compare with the other one, which you call it as microcontroller, so here I had represented is no RAM, ROM, and I/O on the chip. But when you come to the point of microcontroller, in microcontroller it is on chip. That means the RAM and ROM, I/O, timer, serial communication port, which are placed externally in your microprocessor, all are placed integrated on a single chip. Then we call this one as microcontroller. And the same vendors, if you take Motorola has developed a microcontroller and it has been represented as 6811. Similarly, Intel also has manufactured a microcontroller which is represented as 8051. Hence, we call this one as a single chip, where all these components are integrated on a single IC. Then we call this one as microcontroller. If all these components are placed externally to your CPU, then we call this one as means microprocessor. Now finally students, now we make a comparison between what's the differences, overall differences of microprocessor and microcontroller. So when you look out here students, as I told you that microprocessor means it is a standalone. That means the supporting devices such as memory, I/O, timer should be separate. Whereas if you go for microcontroller, all these CPU, RAM, ROM, IO are integrated on a single chip. When all these components are integrated on a single chip, there are a lot of advantages that the occupation of space will be minimized, and also the power utilization also will be less. When the power utilization is less, and ultimately what happens means the speed of your operation will be fast when you compare with your microprocessor. And students, when you move to the second difference, in microprocessor, the advantage is as all these components are placed externally, the designer can design the amount of the RAM, ROM, and IO port required for his application. Whereas if you go for microcontroller, the drawback is as all are integrated on a single chip, so there should be a fixed amount of the ROM and RAM. The third point, your microprocessors are expensive, whereas your microcontrollers are less costlier as all are integrated on a single chip. Then we go for versatility. If you go for versatility, microprocessor is versatile. When you go for microcontroller, it should be used in areas where the cost, power, and space should be critical. Whereas finally, your microprocessor is a multi-purpose. It performs more than one operation. Whereas if you go for a microcontroller, it is used for a single purpose applications. So if you keep on giving an examples of microcontroller means our microwave ovens, or you can say that your washing machines all comes under a concept of microcontroller because they are used to serve only for one purpose. So where and where we are using these microcontrollers for specific applications, then we can say that there will be a reduction in cost and there will be an increase in power, sorry, increase in speed, and there will be a reduction in power. Similarly, all these components are integrated on a single chip, which reduces the occupation area. That's the differences between the microprocessors and microcontroller. Students, go through this video. We will meet with one more video.